Problem 170 requires you to find the area of the region enclosed by the curves y equals x cubed minus 8x squared plus 20x and y equals x squared plus 8x. This line on the graph is the first equation and the parabola is the second equation. So first you need to find the points of intersection, and you can do that by setting the two equations equal together. So you start off by having x cubed minus 8x squared plus 20x equals negative x squared minus 8x. You want to move both terms to the side and set them equal to 0, so your equation turns into x cubed minus 7x squared minus 12x equals 0. Factor out an x, so it becomes x times x squared minus 7x plus 12x equals 0. Factor it out even further, so it's x minus 3, or x times x minus 3 times x minus 4 equals 0. And you set them all equal to 0, and then you get x equals 0, x equals 3, and x equals 4, and these are your 3 points of inflection. Now, in order to find the area, there are two regions that you need to find the area for. You need to find the area for this region and the area for this region. So the area of the first region is bounded by 0 to 3, and the second region is 3 to 4. And so you use an integral of your lower boundary 0 to your upper boundary 3, and it's the top equation minus the bottom equation. So for the first set, it's the integral of 0 to 3 of x cubed minus 8x squared plus 20x minus negative x squared plus 8x dx. But you need to add this area, to the area of the second piece, where your lower boundary is 3 and your upper boundary is 4. But in this case, the parabola is the top one. So you start out with negative x squared plus 8x minus x cubed minus 8x squared plus 20x dx. Simplify those out by combining like terms. So your two integrals are the integral of 0 to 3 of x cubed minus 7x squared plus 12x dx plus the integral from 3 to 4 of negative x cubed minus 7x squared minus 12x dx. Then we find a big F of x of each of these equations and set them up here. So big F of x of this equation is x to the 4th over 4 minus 7x cubed over 3 plus 12x squared over 2 from 0 to 3. And then big F of x of this equation is negative x to the 4th over 4 plus 7x cubed over 3 minus 12x squared over 2 from 3 to 4. Then you plug in each of the values into both equations. So you start out with the upper boundary of the first equation. So it becomes 3 to the 4th over 4 minus 7 to the 3rd cubed over 3 plus 12 times 3 squared over 2. You plug in, then you subtract the lower boundary. So it's 0 to the 4th over 4, 7 times 0 cubed over 3, plus 12 times 0 squared over 2. And then I just left the second equation the same to do later. So this part simplifies to 81 over 4 minus 63 plus 54. And then all these cancel out because they're multiplied by 0. Then you add the second part, so we're plugging in the upper boundary of 4 into this set of equations. So it becomes negative 4 to the 4th over 4 plus 7 times 4 cubed over 3 minus 12 4 squared over 2 minus negative 3 fourths over 4, or sorry, yeah, once we do the first three terms, plug in the lower boundary, you subtract the lower boundary of these, so it becomes minus negative 3 fourths over 4 plus 7 times 3 cubed over 3 minus 12 3 squared over 2. Simplify that out, still 81 over 4 minus 63 plus 54 minus 64 plus 448 over 3 minus 96 plus 81 over 4 minus 63 plus 54. And simplify all that out, you get 71 over 6 units squared, which is approximately 11.33 units squared.